Class, we are going to discuss center of mass, center of gravity, and centroid. What I have seen, students generally remain confused in these three terms. They are unable to differentiate between these three terms, and they don't know the similarity among these three terms. So throughout engineering, they remain confused with all these three terms when to apply which concept. Also, these three concepts has very important role in engineering because directly or indirectly they are used in many different concepts. So it is very important for all the students to understand what is center of mass, what is center of gravity, and what is centroid. Okay, let us try to understand. This is myself, Anubhav Parasar. Okay, let us discuss what exactly is center of mass first. Let us consider an example to understand center of mass. Let us assume that a person he throws a rod AB in the air, and while throwing he also spins it. So the rod A is traveling in the air along with spinning along some axis. Now, if you want to determine the motion of any particle, let me say particle A, point A. If you see the motion of point A, it is very difficult to trace the motion. I am unable to see how is the motion of point A happening. Let us take some other point like point B. If you see point B, it is very difficult to understand the motion of point B. So along the rod, since it is spinning and traveling in the air, it is very difficult for us to determine the position and motion of any other point, except one point you can see, that is the point C. Right? If you see properly, the point C is actually traveling in an accurate path, that is in parabola. This point C, my dear, is called the center of mass. So what exactly is the definition of center of mass? The center of mass is a point where all the mass of the body can be assumed to be concentrated at. So why is center of mass traveling in a parabola whereas other points are not? We are going to discuss this in one of our slides in this class. We are going to see why is it so. But let us first see what is the importance of center of mass. Why is center of mass important? Center of mass is important because it is used in number of concepts throughout physics and engineering. For example, if we say Newton's second law of motion is equal to F is equal to ma, here the acceleration we are talking about is actually acceleration of the center of mass. We are not talking about the acceleration of any other point, but acceleration of center of mass. If you say that the velocity of a rigid body v is v, if the velocity of a rigid body is v, the v we are talking about is actually the velocity of the center of mass. So it is easy to determine the position and motion of the center of mass using laws of motion. And once we determine the position and motion of center of mass with respect to center of mass, it becomes easy to determine the position and motion of the other particles. Because all the other particles, they can either be in rest or having circular motion with respect to center of mass. So if you consider any point A, apart from the center of mass, this is the center of mass. Apart from center of mass, if you consider any point A, the motion and position of A could be really different because it depends, because the body along with translation, it might also have some rotational motion. So the combined effect makes it very difficult for determining the position and motion of center of any point A. But somehow if we can determine the position and motion of center of mass, then with respect to center of mass, I can always determine the position and motion of point A, because point A can only have two possibilities with respect to center of mass, that it could be at rest or it might be having center of it might be having circular motion with respect to center of mass. There is no other possibility for point A. Okay, I hope you got this point. Why is center of mass important? Because only after determining center of mass, we can actually move on to other points, determining the position and motion of other points in the rigid body. Okay, let us see what exactly is center of gravity. Center of gravity, as we know, is the point where the gravity force can be assumed to be acting at. We know Earth pulls each and every body towards its center. We know that Earth pulls each and every body towards its center with force of gravity. Well, if the object we are considering is very small in comparison to Earth, then the force of gravity is constant. For example, for a small body which is quite small in comparison to Earth, the force of gravity is constant, that is mg. However, this is not true if the size of the body is quite big and it is comparable to the size of Earth. In that case, the Earth will have different force of gravity at different points. Because the force of gravity, it changes inversely proportional to the radius. So, what we can say, if the size of the body is very small compared to the size of the Earth, the center of gravity will act at the center of mass itself. What I mean to say is the center of gravity and center of mass will be same. However, if the size of the body is comparable to the size of the Earth, the center of gravity and center of mass might be a different. Might be, nahi, it will be a different point. Okay, I hope you got what exactly center of gravity is. Let us move on to centroid. Centroid is a geometrical shape and it does not have any relationship with mass. It is, if you consider a length, it is the geometrical center of the length where you can assume the whole length to be concentrated at. If you are considering an area, we can consider the centroid to be the center of the area where we can assume the whole area to be concentrated at. Or if you are considering a volume, centroid is the volume of the center of the volume where we can assume the whole volume to be concentrated at. And why do we do so? So that because in engineering it simplifies our calculation. Now, there is no concept of center of mass or center of gravity for area and length. However, if you consider a volume, if the density of the volume is uniform throughout, means mass is evenly distributed throughout the volume, and the volume is small in comparison to the size of the Earth, in that case we can say that the centroid, center of mass, and center of gravity are actually the same point. However, if the density is not uniform, the centroid and center of mass will be different. So will be the center of gravity. Now let us see how to find out the center of gravity and center of mass. So we will start with finding center of gravity and then we will proceed on to center of mass. So let us assume an object. This is not very big. Okay. So let us say this object is composed of many small particles like mass m1, m2, m3, m4. There will be m5, m6, m7, m8, m9, m10, and it will keep on going. Infinite number of particles, right? Infinite number of small particles. Let me say the weight of particle m1 is w1 downwards. Definitely, weight will always be acting down in downward direction. The weight of m2 is w2 downwards. Weight of m3 is w3 downwards. Weight of m4 is w4 downwards. Weight of m5 will be w5 downwards, and so on. The distance of mass m1 is x1. The distance of mass m2 is x2. The distance of mass m3 is x3. The distance of mass m4 is x4. And similarly for mass m5 is x5, and so on. Let us consider the same body, and let us say this is the center of gravity. Let the coordinates of center of gravity, the x coordinates of center of gravity be x bar, and the y coordinate of center of gravity be y bar. So what is center of gravity? Center of gravity is the point where we can assume all the gravity force to be concentrated. Means the whole of gravity force, actually it is acting about the center. So what is the total weight? Total weight is w1 plus w2 plus w3 plus w4 plus w5. So we can say w1 is acting about m1, w2 is acting about m2, w3 is acting about m3, w4 is acting about m4, and so on. Or we can say the total weight w is acting about the center of gravity. So we should be able to use either of this. If these two systems are equivalent, then we should be able to use either of this, right? Here I have neglected the z direction. I have assumed the thickness to be very small and constant throughout, and I have neglected the z direction, and I am deriving the coordinate of center of gravity only in x direction and y direction. I am neglecting z direction. Okay. Now, for both the bodies to be equivalent, the moment of all the weight is a force, right? Weight is a force. The moment of all the weights about z axis should be same for system 1 and system 2. This is also known as Varignon's theorem. Varignon's theorem states that moment in both the bodies should be equal. So if you're taking moment about z-axis for system 1, it will be w1 x1 plus w2 x2 plus w3 x3 plus w4 x4, and so on. And if you take the moment about z-axis for system 2, it will be w into x bar. W is the force downwards and x bar is the perpendicular distance. So if you see from here we can calculate the value of x bar. From here we can calculate the value of x bar. That is equal to w1 x1 plus w2 x2 plus w3 x3 divided by w. This is equal to w1 x1 plus w2 x2 plus w3 x3 plus dot 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 divided by w1 plus w2 plus w3 plus dot dot dot. You can simplify it and we can write x bar as summation of wi xi, I is equal to 1 to n divided by summation of wi, that is the total weight. This is the total weight, right? This is the weight of individual particles multiplied by the x coordinate of individual particle. This is the total weight, right? Similarly, if we rotate the whole system by 90 degree, we can write y bar as summation of wi yi, I is equal to 1 to n divided by summation of wi, I is equal to 1 to n. So these are the coordinates of center of gravity. These equations can be used to find out the location of center of gravity. Now, if we can say that this body which we are considering is very small in comparison to Earth, then we can say the weight, total weight is equal to mg, or I can say w1 equal to m1 g1 n1 g, w2 is equal to m2 g. this G1 and G2, they will be equal to G. Because since the body is small, the gravitational force throughout the body will be same. In that case, we can write W1 WIS MIG, right? WIS MIG, we can cancel out G and we can come up with X. What is X? X is bar is equal to, that is coordinate of center of mass, is equal to summation of Mi xi divided by summation of Mi. Similarly, we can comment about the coordinate of y coordinate of the center of mass, right? So these two formulas will be used to find out the coordinate of the x coordinate and y coordinate of center of mass. So this is valid only when the size of the object is small in comparison to Earth. And this is fairly true for all the objects we deal with in engineering, because all the objects we deal with, even if you consider the biggest of the biggest object, the size of that object will be much smaller than the size of Earth. So invariably the force of gravity remains constant throughout the body. So let us do an example to understand how to apply the formula. Four particles A, B, C, D have masses m, 2m, 3m and 4m respectively and are placed in the orders at the corner of a square of side A. Locate the center of mass. So there are four particles, particle A of mass m, particle B of mass 2m, particle C of mass 3m and particle 4 of mass 4m. So you have to locate the center of mass. Okay, let us see. Let us arrange the particles and write their coordinates. Particle A has, let us consider this as the x-axis and this as the y-axis. So you can see the coordinate of particle A is x coordinate is 0, y coordinate is 0. For particle B, the mass is 2m, x coordinate is A, y coordinate is 0. For particle C, mass is 3m, x coordinate is A and y coordinate is also A. And for particle D, mass is 4m, x coordinate is 0 and y coordinate is A. So let us try to find out the x coordinate of center of mass. So what is the x coordinate of center of mass? m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 divided by m1 plus m2 plus m3 plus m4. If you calculate it, it is coming out to be A divided by 2. So it will be located in the mid plane. It will be located in the mid plane. Similarly, let us try to locate y bar. So it is m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 divided by m1 plus m2 plus m3 plus m4. It is coming out to be 7a by 10. So where is the center of mass? Location of center of mass. The x coordinate is the mid plane and y coordinate is something on the top. So somewhere here will be the center of mass. Let us see here. So somewhere where is the center of mass? So why is the center of mass located here? You can see, if you consider this plane, total mass on the left hand side of the plane is 5m. Total mass on the right hand side of the plane is also 5m. That's why, since they're equally distributed, I can say the center of mass will be lie on the plane that is dividing the whole system into two halves, right? Okay, but if you see the, if you want to see the y coordinate, since the mass above is 4 plus 3, that is 7m, and mass below is m plus m, that is 3m. So that's why the center of mass has shifted from the midpoint to a certain distance towards top. So this is the point. This is the point where you can assume the total mass of 4 plus 3, 7, 8, 9, 10 m to be concentrated at, and you can solve your numericals. Now let us see why is point A and point B, they are not moving in parabolas, whereas point C, which is the center of mass, is moving as a parabola. Now, since this object AB, that is the rod AB, is very small in size, we can assume that the center of mass is itself the center of gravity. So we can say that the gravity force can be assumed to be acting at the center of mass, right? So since the gravity force is acting at center of mass, this point C is actually behaving as a projectile. Point C is behaving as a projectile and it is following a parabolic path. Whereas we cannot say that the gravity force of the whole body is acting at any other point except point C. That's why all other points except point C is not following a projectile motion and hence their path is not a parabola.